In the second part of the lecture, we will be dealing with quantitative analysis approach to decision making. As you know that there are always two types of approaches. One is qualitative approach, one is the quantitative approach. We will be dealing in quantitative approach in this part only. The potential reasons for a quantitative analysis approach to decision making is when the problem is complex, when the problem is very important, when the problem is new, and when the problem is repetitive. In all the cases, we can use quantitative approach. The quantitative approach to decision making is as shown. First of all, we have to identify this situation, and according to situation, we have to carry out survey and we have to draw data out of the situation. And basing on this data, we have to set our problem statement. Then the problem statement deals with the model. When model is made and with the help of different tools, the model is solved and this solution is obtained. And the solution is then tested, and finally this tested solution is implemented to the situation for improvement. So this is the quantitative analysis approach to decision making. Let's solve it. Let's discuss it one by one. First one is the situation. Let's take the example when internal nursing staff not happy with their schedules, hospital using too many external nurses. As hospitals are using too many external nurses, and the nurses, they are not happy with their schedule. So what is the situation? We have to first identify the situation. What is that? It may involve current operations or proposed expansions due to expected market shifts. It may become apparent through consumer complaints or through employee suggestions. Maybe a conscious effort to improve efficiency or response to an unexpected crisis. So we have identified crisis over here, that is this situation. What is the second part? Second part is the data. What does it mean? Data representation is not a trivial step due to the time requirement and the possibility of data collection errors. A model with 50 decision variables and 25 constraints could have over 1300 data elements. So definitely it becomes so difficult to solve it. Often a fairly large database is needed. Information system specialist might be needed. So this is the situation and the data. Second step is the problem formulation. When situation and data obtained, a problem statement is formed. For example, we have to maximize individual nurse preferences subject to demand requirements. The same previous example, we have to maximize individual nurse preferences subject to demand requirements. We have to keep in mind our demand requirements as well, and we have also to maximize their individual preferences. Here we have to define variables. What are all our variables for the situation? We have to define the constraints, that is demand requirements, and finally we have to find out data requirements. What all data is needed? So we have to make the problem statement over here like this. Third step is the constructing a model. We have to construct a model. For example, define relationship between individual nurse assignments and preference violations. Define trade-offs between the use of internal and external nursing resources. So when we have to find out relationship between different or amongst different variables, then it means we are making a model. So problem must be translated from verbal quantitative terms to logical qualitative terms to logical quantitative terms. A logical model is a series of rules usually embodied in a computer program. Then model development. How can this model be developed? Models are representations of real objects or situations. What are they? The forms of models are three types of models: that iconic, analog, and mathematical. So always when we form a model, we have to keep it in mind that they may be out of any three types. First is iconic. They are physical replicas, scalar representations of real objects. Second one, analog models. They are physical in form but do not physically resemble the object being modeled. And then the mathematical model basically represent real world problems through a system of mathematical formulas and expressions based on key assumptions, estimates, or statistical analysis. In this course, we will be generally dealing with mathematical models only, and we will not deal with iconic or analog models. What are the advantages of models? Generally, experimenting with models compared to experimenting with the real situation is that it requires less time. Model basically is less expensive. It involves less risk. So cost benefit considerations must be made in selecting an appropriate mathematical model. Frequently, a less complicated and perhaps less precise model is more appropriate than a more complex and accurate one due to cost and ease of solution considerations. Furthermore, the mathematical model relate decision variables or variable parameters and frequently seek to maximize or minimize some objective function subject to constraints. So mathematical models are said to be stochastic if any of the uncontrollable inputs, that is parameters, is subject to variation, random, otherwise are said to be deterministic. So if there are any of the uncontrollable input is subject to variation, then they are random, otherwise they are deterministic. And otherwise they are deterministic. Basically they are stochastic. So generally, stochastic models are more difficult to analyze. The values of the decision variables that provide the mathematically best output are referred to as the optimal solution for the model. So in this course, we'll be finding out optimal solutions, whether maximized solution or minimized solutions. So in transforming model into inputs or outputs, from inputs to the outputs, basically we have controllable input that are decision variables. With the help of mathematical models, we deal these decision variables, and we do have certain uncontrollable inputs as well that are environmental factors on which we don't have any control. And with the help of mathematical models, we convert these input into outputs that are project results which we require. So this was making a model. Fourth step is solving the mathematical model. How to solve the mathematical model? We do have certain tools to solve mathematical model. And with the help of tools, these models are solved and we find the solution of those models. And definitely we do have certain feedback with the help of these tools to the problem statement. We see whether we are going according to our problem statement or not. If we are not, then we have to align our problem statement again. Okay, many tools are available as discussed before. Some lead to optimal solutions, deterministic models, and others only evaluate candidates, trial and errors to find best course of action. Example is real nurse profiles and demand requirements, apply algorithm, post processes results to get monthly schedules. Okay, what are the model solution? Basically, it involves identifying the values of the decision variables that provide the best output for the model. One approach is trial and error, as already discussed. It might not provide the best solution, inefficient and numerous calculations required. Special solution procedures have been developed for specific mathematical models. Some small models or problems can be solved by hand calculations. Most practical applications require using a computer. There are different computer softwares, as I already discussed. For example, spreadsheet packages such as Microsoft Excel, the Management Scientist MS, quantitative system for business, that is QSB, Lindo, Lingo, quantitative models, the CN Science, DS, other models also, R software, SPSS software. We can use any of these softwares. Model testing and validation is must before using the results any further ahead. So, what is the next one then? The model testing. The tested solution, we have to find a tested solution with the help of certain testing methods. And while doing the testing, we have to keep in mind what was our problem statement and what was our model. Often the goodness and accuracy of a model cannot be assessed until solutions are generated. Small test problems having known or at least expected solutions can be used for model testing and validation. Okay, what is the sixth one? Is the implementation of the model. We have to implement the model, tested solution of the model to these situations. And for that, again, we have to keep in mind what was our problem statement. We have to align all the three things, that is situation, problem statement, and tested solution. And if they are not aligned, we have to rework again. We have to rework and we have to follow the same steps. So this was our complete model. A solution to the problem usually implies changes for some individuals in the organization. Often there is resistance to change, making the implementation difficult. User-friendly system needed. Those affected should go through training. Example is there: implement nurse scheduling system in one unit at a time. Integrate with existing human resource and T&A system, and provide training sessions during the work days. So this is all from my side as long as this lecture is concerned. We will be meeting in the next lecture. Thank you very much.